Okay, PLC. I started the stoplight program. I said do it with 3 subroutines. And the end statement, we went to the timers. And I scroll to the bottom. If I go all the way up to the top, you see that cycle on 20 is going to start timer 1. Timer 1 starts timer 2, etc., all the way through timer 6. And I didn't put in a return yet because I want to put in the blink time, because ultimately you're going to write a basic stoplight, get the basic cycle working. And then I'm going to tell you to go back and add a blink circuit and a cop circuit. So while I'm doing the videos, I'm going to do parts of everything. Okay? At a minimum, you got to have the 6 timers for the normal cycle. And then this will be the addition. So what I got to have is I want my blink timers to work when my cycle is off. So I'm going to choose the normally closed contact. And I'm going to use C20. Well, what that's going to do is my cycle is on, I'll get normal cycle. If my cycle is off, I'll get blink cycle. It's going to be 2 timers, so there'll be T7 and T8. And if you want to jump to T10, T11, you can, because you can do that. But if I use 7 and 8, I will also need T8 to be off, because I want it to reset just like I've got it in the first rung up here. 6 resets 1. So my cycle is on, 6 resets 1. That's how I'm doing cascaded timers. It's an easy way to do it. I won't say it's the only way to do it, because there's more than one way to do anything in PLC. Don't stress about doing it a certain way. What you want to stress about is, can you write a program to do what is asked for? That's where you want to get into it. So I'm up to T7. And my set point, I'm going to go ahead and use D7 because I can see the D6 right here. So I want DS7. Milliseconds is good because usually on my blink timer I use a 1.5 seconds. And if you do seconds, you can't do the half second. So you have to do it milliseconds and have a preset of 1500. I want it to be an on-delay timer and non-retentive, so those are okay. And there's that one. And then when T7 gets done, we want to start T8. So T8 with memory location DS8. This gives me a chance to go in and actually tweak. I'm good with the milliseconds, and I'm clicking OK. All right, now to finish this routine, I need a return statement in there. So let's do that. And so this is all I need for my timers, for my blink time or my regular. So if my cycle's on, I'll get my 6 regular timers. And when my cycle is off, I will get blink time. That's all I need for the timer part. I'm going to go to the output rung next. Actually, I should do stop start. I think that we have X1 as the stop button and X2 as the start button. I could be wrong. And then X3 is your selector switch. So for my output, I'm going to do C20 because that's my cycle on. And what's going to turn on my cycle on? I need my stop button to be on, which if I don't mess it up too bad is X1. Should be a normally closed push button should have to examine it on. You've done this. Hopefully you're comfortable with it. And then X2 needs to be on. And I need a seal in around X2, so I'm going to highlight it, control down. Well, there we go. I need C20 there. Control arrow up, stop start. Stop start with a seal in. I could go into address picker and say this is my stop button, this is my start button if I want to. That's perfectly okay. The other thing though I need is my COP switch, which is a maintain contact. From a safety standpoint, if something goes awry with your stoplight, you want the COP switch to be on, to be normal, and have the cycle start. So if for whatever reason it goes off, it will go, you want your blink cycle to start. So I'm going to put that in there, and that was X3. Okay, so my COP switch has to be on, which is reverse logic. So the officer will switch it to the off position actually, or he will kill the power to it. In his or her mind, it won't matter. All he knows is that, all he or she knows is that they flip the switch, they're going to get blinking lights. And so I want that to happen in my stop start. And I want to also return. So that's stop and start and adding a COP switch. Now, outputs. And outputs are handiest if you go in and you just go in and put in your outputs. So Y1. Ooh, I labeled it north, south, red. Y2. Y3. Y4, Y5, Y6. And then this is going to end up being a return. Now we're going to go in and modify these, but I only got 6 outputs. So I'm going to start over there and say, okay, I got my 6 outputs. Now, I do not have the cycle open, or it would really be good. My north-south red should be on the first 3 cycles. So I'm just going to do this as 3 cycles, and then I'm going to go in and modify. I'm going to go in and modify the logic so the lights will work in the right fashion. If you program this as it is and you download it, all 6 lights will be on. Which isn't a bad thing to do when the PLC is have some kind of program that tests all your lights. Okay, so I need north-south red to be on. While timer number 1 is on, I know. And so I've got to capture the enable logic, the Allen Bradley enable logic, which means I will have C20 on, and I will have timer 6 off. Okay. So I need C20. I need timer 6 off. I need T1 off. Whoops. Got to select the right contact. It won't do it by default. It always does normally open. There you go. T6. No, not T6, T1. Okay. So this enables timer 1, and this tells me timer 1's not done. So this is my timer timing logic for timer 1. Okay. Now I need the timer logic for timer 2, which is, I'm going to control arrow down because it's all got to feed back into this one. So I need T1 to be done, and I need T2 to not be done. Then I'm going to arrow over and arrow up. So I have put in that. So this tells me that this red will be on during timer 1 and timer 2. Well, I need it for 4 cycles, so I've got to keep going down with my branches. I need T2 to be done. And I need T3 to not be done. Over and up. So it's on for the first timer, the second timer, the third timer, and now one more. So I'm going to control arrow down and T3 on, T4 off. Okay. And if you go up here instead of over and up, it's not going to matter. This will get my red light on during the normal cycle for timers 1, 2, 3, and 4. Okay. Now my other red light is going to have similar logic. It's going to need to be on for timers 1, 4, 5, and 6. So I go down to this one and I'm going to say, okay, this one needs to be on for 1, 4, 5, and 6. So I've got to have my cycle on, C20. I've got to have my T6 off. And I've got to have, this is for number 1, right? T1. So there's my timer timing logic for timer 1 timing. And then I said it was 4, 5, and 6, right? So I'm going to arrow down. T4 needs to be timing but not done, so T3 will be done. And T4 will not be done. Over and up. And then I need 4, 5, and 6. So that's T1, T4. Now I need T5 and T6. Control arrow down. So I need T4 to be done. And with the red lights, you can shorten this logic. It's easy to do, but I'm going to leave that for you to figure out if you can. Because if you write it like this, somebody will come on, why didn't you do it this way? Well, that's what happens in PLC. The key thing is, does it work? So you don't have to do it this way. You can do it any way that works. All right. And so I need T5, and I need T6. And I'm not doing the blinks yet. They will have to be added later. I'm just getting the normal cycle here to go. Whoops. I don't know what I did. There's a way to check the syntax. Is it going to get rid of it? Yeah. Somehow I got an extra space. I went in and I checked syntax, and it took care of it. All right, so this is my 2 reds, my stop start, and my timers. Okay, yellow and green's easier. Once we get them going, then we'll come back and do the blink and the cop cycle. But we're about 15 minutes, so I'm going to stop here.